Hey folks, I want to let you guys in on some secrets to solving the problems that we need to solve in this chapter. Everything has to do with proportions. And so we're going to use the concept of proportions over and over again as opposed to memorizing some formula. In this case, we know the diameter and oh, maybe this one we won't even need a proportion, we'll see. Anyways, in this case we know the diameter and we want to find the arc length AB. Well, the thing is this, maybe we will use a proportion, let's see. So it turns out that the area of the entire circle is, oops, not the area. We're working with just arc length. So the circumference of the circle is 2 pi r. And because we know the diameter is 8 feet, we know the radius is 4. So our circumference is going to be 2 pi 4, which we can abbreviate as 8 pi. Now that's all the way around the entire circle. Okay, we just want to know this part right here. And it turns out this part right here is just a fraction of the circle. And the fraction of the circle that it is it's 45 out of 360 degrees. Okay, so let's go ahead and use different ink to make it look kind of pretty. We're going to say 45 over 360, and it looks like, yes, we're going to need a proportion. And we're going to compare that to the circumference of the entire circle, which we calculated to be 8 pi. And we put that down in the bottom of this fraction because 360 degrees, which is all the degrees in the circle, matches up with 8 pi, which is the entire circumference of the circle. Then we compare the 360 degrees to the 45 degrees, and what we'd like to know is what is the arc length just from here? Well, the arc length just from here is some portion of this 8 pi, and so we can put x here, but I think to make things more clear, I'm going to write it the arc length of AB. That's what goes here. It matches up with the 45 degrees and it matches up with the circumference, okay? This is a measurement not in degrees, but in length. In fact, it's going to be in feet because the diameter is in feet. So then we do a little cross multiply, just because we love to, because it's so fun. And, oh, look at this. It's looking a little Christmassy, isn't it? A little red and green. So anyways, let's go ahead and multiply this stuff together. And when we do, we get 360 times the arc length, AB. By the way, I wouldn't mind rewriting that arc length AB as x, but for now I'm just going to leave it like this, so hopefully it's clear to you what's going on. And then 45 times 8 pi. And then we divide both sides by 360. And what I want to encourage you folks to consider is practice writing stuff out like I am, as opposed to practice getting the answer using your calculator. See, getting the answer using your calculator is only helpful if you know all this other stuff. And the only way that you get really good at this other stuff is if you practice it. So practicing the art form of writing is important here. We're going to do 45 times 8 pi, and that's all over, divided by 360. And then let's cancel. And again, no calculator. Try to cancel as best you can without it. 8 and 360s, they're both even numbers. 45 and 360 can both be divided by 5. We have a number of ways to simplify this. I'm going to go ahead and try the 8 and the 360. Let's go ahead and do some canceling here. Say bye. So that'll be 4 and 180. And again, that can be canceled again. So divide both those by 2. That gets me 90 and 2. And what do you know, Joe? If I cancel that 2 and that 90, I get 45 and 1. And voila, I get to cancel this 45 and this 45. And arc length of AB looks like it's just going to be pi. That is pretty dang cool in my estimation. So let me go ahead and write that out. It looks like arc length of AB is going to be equal to pi. It's an exact answer, and I didn't need to use a calculator to do it, and I got to practice using my brain and using my writing skills. Let's go ahead and let's try some more. Oh, one last little detail. In this case, we can see in the problem, it tells us to put the pi there. Oh, by the way, it says the arc length is about and round to the nearest hundredth. So I guess technically, if we had to enter this online, we would have done something like 3.14. That would have been round to the nearest hundredth for pi. Put that in that box. They gave us the units. For us, though, we'll go ahead and we'll write feet. And they say about 3.14. We can say equal because pi is exact. It's exactly pi feet. Okay, just wanted to finish that one off. Let's move on. So, next problem is, this time we're given the arc length and degrees, and we'd like to find the circumference. So let's do the math. Again, we're going to use a proportion. We know that the entire area of the circle is supposed to be, I'm sorry, not area again, circumference is 2 pi r. Let's see here. And what we have is just that arc length. So let's see. We say definitely 76 out of 360 degrees. That's how much 7.5 is. And so we'll put the 7.5 meters over here where the 76 degrees is. And then down here is the circumference that we're looking for. And I don't even know that we need the 2 pi r. I could just put a big C here for circumference. I'm a little concerned about writing C because there is a C here also. So I guess maybe I'll actually write out circ for, short for circumference. And let's go ahead and do the math. So we cross multiply and we get 76 circ equals 7.5 times 360. And this is a process that I want you guys to go through over and over again. The more you go through this, the more comfortable you'll be with it. And again, one really good thing is to go back through these videos, hit pause, try to do it on your own, and then see if you agree with me. Okay, so this gives me 7.5, 360, and if you guys could do this much, I would be so happy. Now we can go ahead and throw this result into the calculator and see what that gets us. We could do some canceling first, of course, but I think this time I'm just going to go for the calculator. Alright, so I punched the numbers into the calculator, and hopefully I did it correctly. You'll let me know if I made a mistake. I got this number here. And one of the reasons why I don't just go and tell you what that is, I want you to pause the video. It says round your answer to the nearest hundredth. One problem that I've noticed many students have is they don't know what that means. They don't know how to take this and round to the nearest hundredth. They're not sure what to do. I'd like you to pause the video. Look at this number and see if you can figure out how to round this to the nearest hundredth. Okay, hopefully you've taken the time to do that, and I'm going to go ahead and write out what I think it is. And since we're rounding, we'll put approximately. And let's see here. Now, don't let me steal your joy. Don't cheat. You got to figure it out. So I want you to think about it if you haven't already. Okay, here I go. I'm going to say that I think it's going to be 35.53. That this is the tenths place, this is the hundredths place, and since the thousandths place is 6, I'm going to round this 2 to a 3. So 35.53. Let me see if I can get that. There we go. All right, and sorry that looks so messy. We'll rewrite it over here, nice and clean. 35.53. And again, meters is the units, and we can box that as our answer. All right, okay. All right, in this problem, we got to find the radius of a circle when we're given the area. I don't think it's that big of a deal, but I like the fact that there's no picture. You got to draw your own, and you should be drawing your own picture. That's a very valuable problem-solving skill is draw a picture to help visualize what you're trying to solve for. So in this case, there's a circle, and we want to know the radius, and we're told that the area of the circle is equal to 89 square feet. Or 89 feet squared is another way to write that. And so one thing that we know about circles is that in circles, the area is going to be equal to pi r squared. This is something that I expect you to know, and I expect you not to mix it up with circumference. I don't know that you're going to get an index card for that. Okay, so then we want to find the radius, and the good news is we know the area, and over here is r, and pi is just a number. It's not a variable. So we know a, and we want to find r, so it shouldn't be too big of a deal. So we go ahead and put in the 89 where a is, and it's equal to pi. And again, put that calculator down and start writing along with me. Get in a habit of writing this stuff out. We're going to divide both sides by pi to get r all by itself. And again, if you want to pause the video and work ahead, that's cool. Let's see here. And if I divide both sides by pi, then these pi's cancel. These just go away. And so I get r squared equals 89 over pi. So I'm going to go ahead and rewrite that. I always like having my variable on the left-hand side. So r squared equals 89 over pi. And to get rid of the r squared, do you remember what to do? If you don't, pause the video and think about it for a minute. Otherwise, I'm about to tell you. Okay, I think what we do to get rid of that r squared is we're going to go ahead and we are going to square root. So I'm going to go ahead and put a square root there. That makes it into just plain old r. And then if we square root one side, we'll square root the other side. And so that is the square root of 89 over pi. Now, if we had to do this exactly, we'd probably have to rationalize the denominator. But in this case, they're asking us round to the nearest hundredth. So we can just put these numbers into the calculator and go for it there. I don't even think I'm going to finish it off. I don't even think I'm going to give you the answer. The main thing that I wanted to show you is this is the technique for getting the answer. And to me, knowing this is more important than the number that you get after doing all of this. So make sure that if we go through this entire review, make sure you can go back to this video, hit pause, and do all this on your own before you ever pick up a calculator. Okay, find the area of the sectors formed by DFE, and it looks like they want us to find the area of the red sector and the blue sector. To save time, I'm simply going to find the area of one of those two, and I'll let you work on the other one yourself. One thing you can do is find the area of the entire circle and subtract whatever I get to find the other side, and then try the other side using the same technique I'm using and see if it matches. Anyways, let's go and find one of these two. I guess I'll just find the blue one since they tell me it's 256 degrees. And again, we're going to use a proportion. We're going to by the way, pause the video if you want to try it yourself before I explain. Okay, did you try it yourself? Here we go. I'm going to start. Okay, so the blue section is 256 360ths of the circle. That's what fraction of the circle it is. And then area. So in this case, finally, I get to use this area equals pi r squared. I was using, I kept thinking I was doing area before when I was doing circumference. In this case, the radius is 14. So the area of the whole circle goes with the 360 degrees. So that's pi times 14 squared. And then the area of the sector is what I don't know. So I could call it x, but I'm going to call it I don't know, I could call it blue or I could call it DFE or I could call it blue. I think in this case, since DFE could be blue or red, I think I'm just going to call it blue if you don't mind. There we go. It's the area of that sector, so I don't have a symbol for it. So we're going to do cross multiply and figure out what blue is. So I get, let's use a different color. 360 times blue, that's how we cross multiply, and then 256 times pi times 14 squared, I think that's 196. You'll correct me later if I got that wrong. And blue is equal to, we'll divide both sides by 360. Again, I want you guys to practice the skill of writing this stuff out, not getting the calculator out and getting the answer, because honestly, If you can't do this part, getting the calculator out and doing the rest is just, it doesn't do anything. It doesn't show you understand. This is the part that shows you understand. Now, I have to admit these numbers are kind of big, so I'm not going to ask you guys to cancel manually here, not right now. Here we could just go ahead and use the calculator, but this is the exact answer. And I think I'm just going to let you guys do the calculator, and I'm just going to say that's it for now. I wanted you to see how to set up the proportion and then how to get the blue all by itself and write out the exact answer in terms of pi. If we had to enter the exact answer into the online software, then we would cancel these guys until they were as simply as they could possibly be. Okay, I'm going to leave that one alone and keep moving along. Okay, this is my last example of review example for circumference, area, arc length, and sectors. So let's go ahead and take a look at what's going on here. All right, in this problem it says the area of the shaded sector shown. Find the radius. So let's see what we can do. We're going to try to use a proportion to relate this information. We see 89 degrees is the central angle for this sector. So 89 out of, we know, 360 degrees in a circle. And we can figure out the, we know the area of the sector. It's 12.36 meters squared. And what we don't know is the area of the entire circle. And more importantly, what we'd like to know is the radius. Well, here's the thing, is if we know the area of the entire circle, then we can figure out the radius, because the area of the circle is directly related to the radius by this multiplier pi. So if we can figure out the area, we divide by pi and we square root and we'll get what the radius is. So the area right now is what we're looking for first, and then we'll go and solve for our second. So I'm going to go ahead and write down a here, and that's what we're solving for, and we'll use cross multiply to do it. So 89a equals 12.36 times 360. And again, to me, the most important thing is you write all this down. And even more importantly than that, it'd be better if you did it on your own, if you paused the video and finished it off yourself, or if you came back to this video and hit pause and did the whole problem yourself from scratch up until this point. That would be great. Once we find the area, we can then make that into a number. And once we get that number, we set it equal to pi r squared. And again, we just, we do this. Let's go ahead and write this out. We're going to do r squared equals the area divided by pi. Take the square root of both sides, and r will equal area divided by pi square rooted. Now, I know that sometimes it's difficult to get the exact number you're supposed to get in here, and that's the least of my concerns. When you go to take the test, you're going to be in your best situation if you know how to do all this. If you're not getting exactly this answer, that's okay. The online classwork is not a whole lot of points compared to the test. And furthermore, I want you guys to have skills that you can use in life and in other math classes. And understanding all of this is going to help you in that regard. Okay, I'm not going to write out any more numbers. I'm just going to leave it at that. And that's the end of my circumference, area, arc length, and sector review for Chapter 11.